Okay, so I made a few videos on sea life and ocean stuff, and I've proven that I can't pronounce anything worth shit. But another topic that's pretty vague but is super interesting is space and like life, other places and stuff, and the an essential piece to making life sustainable is water. And so I saw this article, and it was super interesting, and so I wanted to read it. It's about Mars and possibly like remnants of water and evidence and shit like that. So I'm gonna just read the article for you guys and tell you about it. So the article states as the title, China's Zhurong Mars rover finds evidence of water in Martian sand dunes. The Zhurong rover has found evidence of water on dune surfaces on modern Mars by providing key observational proof of liquid water at low Martian latitudes, according to a study led by Professor Quinn from the Institute of Geology and Geophysics (IGG) of the Chinese Academy of Science (CAS). The study was published on April 28th in the journal Science Advances. Researchers from the National Astronomical Observatories of CAS and the Institute of Atmospheric Physics of CAS were also involved in the study. Previous studies have provided proof of a large amount of water on early Mars, but with the escape of the early Martian atmosphere during the later period, the climate changed dramatically. Very low pressure and water vapor content make it difficult for liquid water to sustainably exist on Mars today. Thus, it has been widely believed that water can only exist there in solid or gaseous forms. Nonetheless, droplets observed on the Phoenix robotic arm prove that salty liquid water can appear in the summer at current high latitudes on Mars. Numerical simulations have also shown that climatic conditions suitable for liquid water can briefly occur in certain areas of Mars today. Until now, though, no evidence has been shown the presence of liquid water at low latitudes on Mars. However, findings from the Zhurong rover fill the gap. The Zhurong rover, which is part of the Chinese Tianwen 1 Mars exploration mission, successfully landed on Mars on May 15, 2021. The landing site is located on the southern edge of the Utopia Planitia UP plane, where the Northern Lowlands unit is located. The researchers used data obtained by the Navigation and Terrain camera, the multispectral camera, and the Mars Surface Composition Detector aboard the Zhurong rover to study the different scale surface features and material compositions of dunes in the landing area. They found some important morphological features on the dune dune surfaces such as crust cracks, granulations, polygonal ridges, and strip-like trace. The analysis of spectral data revealed that the dune's superficial layer is rich in hydrated sulfates, hydrated silica, especially opal CT, trivalent iron oxide minerals, especially ferrihydrite, and possibly chlorides. In quotes, according to the measured meteorological data by Zhurong and other Mars rovers, we inferred that these dune surfaces characteristics were related to the involvement of liquid saline water formed by subsequent melting of frost/snow falling on the salt-containing dune surfaces when cooling occurs, said Professor Quinn. Specifically, salt and dune caused frost to snow melt at low temperatures to form salty liquid water. When the saline water dries, the precipitated hydrate sulfate, opal, iron oxide, and other hydrated materials cement sand particles to form sand aggregates and even crust. Then the crust is further cracked by shrinkage. The later frost/snow melting process further forms polygonal ridges and strip-like trace on the crust surface. The estimated age of the dunes, about 0.4 to 1.4 million years, and the relationship among the three phases of the water suggests that the transfer of water vapor from the polar ice sheet toward the equator during the large obliquity stage of Mars's late Amazonian period led to repeated humid environments at low latitudes. Therefore, a scenario of water activity has been proposed, i.e., cooling at low latitudes during Mars's large obliquity stages prompts frost/snow to fall and subsequently results in the formation of crust and aggregates on the salty dune surfaces, thus solidifying dunes and leaving traces of liquid saline water activity. The discovery provides key observational evidence of liquid water at Martian low latitudes, where the surface temperatures are relatively warmer and more suitable for life than at high latitudes. Quote, "This is important for understanding the evolutionary history of the Martian climate, looking for a habitable environment and providing key clues for the future search for life," said Professor Quinn. Yeah, so that's just describing how they have a bit of evidence to show that water was once on Mars through like the cracks and different patterns and stuff on the surface and such. And they've it's been public now, but they're trying to see if Mars is suitable for human life to move over there eventually and stuff. And I just think all of it's super interesting because the possibility of water means the possibility of life at one point, meaning that aliens did exist, even if they don't now, they did. And it's just super interesting to me, but that's all I had to say.